Let's continue and let's go to the last presenter. But I have to say something after him. During the beer bar, there's two lightning talks of 5 minutes each, and they will be talking about something interesting as well. So stay tuned. It will be in this room as well. So stay tuned. It's very important. Can I have your attention, please? I would like to introduce the next speaker. His name is Adrien, and he's French and 30 years old. That's why I received 30 years, right? Soon 31. Soon 31. Yeah, just upgrade. And he's a dad and triathlete and full stack engineer and CTO at Mirai Denshi. So he would like to talk about machine learning for small data. Adrien, please.
Okay. Hi everybody, nice to meet you. So my name is Adrien, but everybody calls me Dolly. As you said, I will talk about machine learning. So as a CTO, software engineer, and passionate by data science, I will approach this problem through these three angles. So at Mirai Denshi, the company I'm working at, we are building a service called Go Unite, which aims to bridge the gap between companies and students in Japan. For companies, they can improve their image and get free PR, and for students, they get real field experience through curriculums. One of the main features is the Go score, which represents the satisfaction of a student after they completed an experience. So this is a nice number to show the appeal of a host. But right now, with few data, it's easily influenced by some factors like, let's say, the mood of the student at the time he completed the survey. So ideally, we'd like to offer some recommendation system that would be personalized for each students, but this will require us to gather a lot of data, and it will take a few years. And I was wondering if there wasn't anything that could be done to improve the current system until then. So that's why I started investigating what can be done with small data, and I will share my insight today. So as a business, you're confronted with a lot of constraints, money, time, but also accuracy level. Like, can you afford to put on production a model that is only 90% accurate? If not, then you will need to invest more time and money to improve it. And therefore, as a business, you need first to understand your problem. There is a nice framework called the Drivetrain Approach. For us at Go Unite, for a student perspective, the objective will be what company do I want to have an experience with? The levers that we have are all the information that we display on the host page, including that Go score, but also the way we order all the hosts in our experience center. So which host do we show first, etc. The data that we can collect are all those survey results from the students, but also blog posts that are written about those experiences, and also all the interactions of our users in our website. So how long does a student spend on such host page, and also some other features like voting, interest gauge, etc. So our model will be an ongoing experimentation and an improvement of indicators for our host. So now, when you understand your problem, first, maybe you should consult a statistician. Maybe you don't even need to do machine learning. Maybe a small statistical model could yield good enough accuracies that will lead to quick results, right? But let's say your data is too complex to build a simple statistical model. Then the next step would be to consult Kaggle. Kaggle is the world's biggest community of data scientists where experts around the world collaborate together to solve business challenges. So when we explained what was Go Unite about and what we wanted to do with the Go score, well, they helped us to understand that we will need to collect at least 10,000 experiences in order to build a deep learning, to host a deep learning competition on their platform. And that will take a few years to collect all this data, but at least it makes for a very nice KPI. So then your data is too complex for a statistical model and you don't have enough data to do deep learning with Kaggle. The next step is to assess like how much data is enough for you to start building a simpler machine learning model, right? The thing is there is no simple answer. It is really domain dependent. It depends on what kind of problem you're trying to solve and also the data type that you have available. One fact is that the number of data points that you need is a factor of the number of parameters or features that you have. So if you can use domain expertise to evaluate your data and reduce the number of features that you need, then as a proportion you will need less data. Also, if you do not own many data, maybe you can augment it using publicly available data sets on the internet. There are a lot of data that are correlated to what you're trying to do. And for example, we could use statistics of Japan to help us figure out what are the sectors that are becoming popular with youngsters these days. And therefore, if one of our hosts is part of the sector, we can infer that this host is becoming more appealing to our students as well. Next, even if you understand that you don't have enough data or that you don't have enough resources to commit to such projects, there is one step that you really need to take to start doing right away. It's to make your data machine learning friendly. We had this big issue at Mila-Denchi where lots of correlated data were spread across many different locations. Also, some similar fields like dates will be stored in different formats. So it makes it very hard when you want to work with those data to collect it, aggregate it, clean it, etc. So the longer you wait and the more costly it will become. If you can do this right from the beginning, it will also speed up your process in the end. So as a business, you want to use domain expertise to understand your problem, and then you want to consult statistician or Kaggle, and finally make sure that you keep your data tidied. So now, as a software engineer, I wanted to dive into this myself. There are a lot of misconceptions like you need to be a mathematician or to hold a PhD in order to do data science, which is completely wrong. As a software engineer, you have many of the skills that are required to do data science, and you can become an excellent data scientist. Of course, software engineering and data science are worlds apart. If you look at the cycle of a software development, software engineering is all about working on a production code, so you care about tests, about good naming, about refactoring, etc. But data science is all about prototyping. You want to try as many models as possible, to try as many hyperparameters as possible to see which one will yield the best results, right? So really, iterating fast is the key. Then, as a software engineer, I realized that what is the most important is focus on learning meta-knowledge. You do not really care about the mathematics and all the low-level stuff. Lots of libraries have already implemented all those algorithms and optimize them. So really what you want to learn is how to use those libraries and when to use them to solve depending on your problem. Also, when I got started, I spent a lot of time to install all the libraries that I needed and deal with all the package conflicts and stuff to try to build the cheapest setup on AWS and Google Cloud Platform. Well, I just lost a lot of time. Today, you have plenty of services that cost a few pennies an hour that are highly customizable. You can enable, disable GPU as you want. And they also come preloaded with all the libraries that you might want to use. So really my advice is don't lose time on this, use the services and get started right away. Also, when I started learning machine learning, I started with theoretical courses, so a lot of maths and stuff. Well, that was fun, but after a few months, I had forgotten everything already. Then I learned again using this time a practical machine learning course, and that forced me to put what I learned into application right away. And that helped me to gain experience and to deepen my understanding and strengthen my learning. So I really recommend paid course like Udacity or Coursera, but also free courses like the School.ai or FastAI. I really recommend that one. Finally, there's no secret. Practice makes for experience. You really want to train on Kaggle competition as much as possible. They have lots of levels of competitions, and really you want to do as many mistakes as possible on Kaggle, not on a production project that will cost lots of money, right? Also, since you're working with other experts around the world, by collaborating with them on Kaggle, you will be able to learn a lot from them, and your knowledge will increase by leaps. Finally, last tip for software engineers is to master one visualization library. If you don't understand all the low-level stuff, at least understand your data. So what is your data, and how does it get transformed as through your experimentations? I discovered libraries like Plot9 and ggplot, which implement the grammar of graphics. This allows you to concatenate rules for data, for aesthetics, and for layers in a very intuitive way for software engineers that also result in very nice charts, even if you're not a designer. So this is not known enough, and you should really have a look at it. So as a software engineer, be more confident. You don't need a PhD. You can get started right away. Focus on meta knowledge and play a lot on Kaggle. So now looking at the small details for data science. Well, the common problems that we have with small data are overfitting. Overfitting means that you can build a model that is very accurate on the data that you gave it, but it will perform poorly on new data. Another problem is outliers. Let's say you have a numerical data type, and most data are within a range, but you have a few exceptions that are orders of magnitude apart. Well, your model might wrongly infer that those exceptions are more important than the rest of the data, and then it will build an incorrect model. So you need to be careful with this. And finally, noise. We are working with real life data, right? Data that is often input by humans who make mistakes. So you have a lot of incorrect data. You have even more missing data. Well, you need to clean your data and to fill out all of the missing data in order to increase your accuracy. Filling missing data means looking at your data and figuring out what would be a good default value for it. Let's say it's 0 or the average of all the values, stuff like this. To deal with overfitting and with outliers, apply smoothing techniques like regulations or averaging, stuff like this. Also, stick to simple models. Pull all your data and use a domain expertise to do feature selection. The less features you have, and the better your model will be able to generalize on this data. Also, you need to quantify uncertainty. So let's say your model made a bunch of predictions and you're trying to plot them in a line. Well, all you see are the results of this prediction, but you're missing a very important part, which is how confident was the model in making this prediction. So let's say